Mr. Lesham here, and we're starting a new chapter, and that is trig. So what we're going to do today is really just pure revision lesson. I'm going to remind you the basic bits of trig, not all of it, and then we're going to go to one kind of question which we already did, and it's quite difficult. It's solving a trig equation with a graph. Alright, so let's start with what we call the Cartesian plane, okay? And I'm going to start with, let's call this an angle, okay? We always measure angle, is this on by the way, it is, from the x-axis, from the positive side of the x-axis. So that, what do we call the letter by the way, do you remember? Theta. Just a little bit of background, theta, okay? Now, then we look at the basic relationship, okay? Sine theta, cosine theta, and tan theta. I know there were a couple more that we learned last year, but we're not going to deal with them now. They're not as really important, okay? Now, I'm going straight away to the Cartesian plane, okay? R is what I'm going to call the hypotenuse. It's the distance from the origin, okay? The sine theta, what is sine theta? Do you remember?
Opposite
over hypotenuse. Can I write it? You're gonna know. Oh, let's say
Sokotoa.
Yeah, Sokotoa. Okay, opposite over hypotenuse. In other words, it's really the y over the r. Let's do it in black, so it's all nice. Okay. So it's the y coordinate divided by r. Okay? Now, cosine theta, what is cosine theta? Do you remember? Adjacent divided by hypotenuse. What is the adjacent?
The y.
The x. It's the x coordinate. So it's the x over the r. Okay? Just leave it. Chemistry, I don't like chemistry. Okay. Tan theta, guys. Tan theta. What is tan theta?
Opposite
over adjacent. So in other words, it's going to be the y coordinate divided by the x. Okay, and I'll just pause here to see if we've got any questions. So now we're going to move on and looking at all the different quadrants, what we call quadrants. But before that, I'm going to write down something here which you know about it, but I didn't really talk about it last year. I don't think I did. If I take the adjacent side, x squared, and I add the y squared, what should I get?
R squared.
I should get r squared. Okay, what do we call this theorem? Pythagoras. Okay, because this is a right angle triangle. So we will come back and we'll use it. Not now, not tomorrow, but we will use it later on. So don't forget about that. Now we gotta put some quadrants. So we call this quadrant 1. This is quadrant 2, 3, and 4. And what we're trying to do is find out when are the sine, the cosine, and tan, when are they positive, and when are they negative. Okay, do you remember that one?
Yes, sir.
Let's start with the way the phrase that we taught you. Okay, I didn't have most of you, but what was the phrase to remind us which one are positive?
Cos.
The first and the third one.
Yeah. Okay. What the way I told it is I learned that all students take Coke. That's obviously not okay. Okay. Coca-Cola. Okay. All students take Coke. It's like cars, but starting from here.
Wait, hold on. How did...
Just try and remember that phrase. Nah, just pause. Yeah. So what are we getting from it? What are we getting from it? Okay. What we're asking ourselves, when are the sine, cosine, tan, when are they positive? So all really means all of them. Okay. So sine is positive, cos is positive, and tan is positive. They're all positive. Okay. S, what does S stand for? Sine. So it's just sine, not cosine, just sine. Only the sine is positive. That means that the rest are negative. Okay? And then T, what does that stand for? Tan. So the tan is positive. That means the sine and the cosine are negative. Okay, understand. Okay, and then Coke, what does that stand for? See?
The x
Cos.
is positive.
The cos are positive. That means the sine and the tan are negative. So that's how we remember it. It's a nice, quick way of remembering. But actually, I want you to understand it. Okay? So I've heard already some of you mentioning here. Okay? Why is this? Let's start with the sine. Why is this? But let's first of all look where the sine is positive. The sine is positive at the first and at the second. Can you see that both these quadrants, the sine is positive? But why is it? Yes. It's above the x-axis. Now what is sine? Sine is y over r. R is always a positive number, it's hypotenuse. But the y, when is the y positive? As long as we're above. Because anywhere here, the y is positive. So sine is going to be positive here and here. Cool. Eh? Right. Cosine. When is the cosine positive?
Third and
First and fourth. Why is that? What's positive? What is cosine? Cosine is x over r. Right? X over r. So when is x positive? Well, here and here. Anywhere on this side, we'll have a positive x. Okay? So cosine is positive here and here, and it's negative here and here. Tan is the only one was a bit funny. Where is the tan positive?
First quadrant.
First and third. Now, why does that happen? Well, tan is y over x. So if y and x are positive, positive divided by positive is going to be positive. But they can also be the other option. They can be both negative, and then negative divided by negative is also positive. So tan is negative here, and positive here and here, negative there and there. I'll pause here for questions. Right, we're back in business. Okay, so now we're doing the first kind of problem. We've done it last year, but it's a difficult one. And as I told you last year, this was already matric level. So normally we kind of learn, let's say, a quadratic equation in grade 10, then we push it up a little bit in grade 11, and we add one little thing in grade 12, and then you can do question. But this kind of question is already ready. It's a matric question. And every matric question, paper will have one question like that. So they tell you 3 tan theta minus 4 is equal to 0. And theta, what is this thing? That funny euro sign. It belongs to the set. This is a set. So it's basically, it means that the angle is between 180 to 360. So it's either the second, let's draw, might as well draw the quadrants. So which quadrant can it be?
Second one.
Second or?
Fourth one.
Not second, it can't be second. It's from the third to the fourth.
What? Yeah.
180 is already here. It's more than 180.
Oh.
Okay? Alright, I mean it could be on the edge in between. Okay? Right, and they're asking us determine 25 sine square theta. Okay, that means square of sine minus 5 cosine.
So it's not the third and the fourth. Because the third one is 270.
Yeah, exactly.
270 is here. That's 180. So it's between 180 to 360.
So, but not including 180 and not including 360.
Yeah, correct. So it's 180. It's third or fourth. Okay. Okay. Right. Now, what they're telling you here, you need to use a diagram, and I didn't write down. Also, they tell you not to use a calculator. So first of all, let me just show you how you would do it if you did use a calculator. And that will be actually in itself a good recap. If, let's say, they didn't talk about diagrams and calculator, then you just take that, 3 tan theta equal 4. Can I already move that around? Okay?
Yes, sir.
Then we're going to say, okay, that means tan theta equal 4 over 3. Okay? And then we also learn how to find theta here. How do we find theta? I want the angle, if I know the ratio. It's the inverse tan, or we can call it tan minus 1, or sometimes we call it arctan. Okay? So tan minus 1 of 4 over 3, and you get an answer. Okay? Can we actually just find out? Can you do that for me for a second? So if we, guys, if we, never mind if the answer is not right, I'm just giving you a principle here. If we could use a calculator, you just rearrange this equation, you find what the angle is, 59,03, and then you substitute it here. So then you'll say, okay, they want me to find that is no problem. I already know the angle, so it's sine square of 59,03 minus 5 cosine of 59,03. You put that in the calculator, you got the answer.
Oh.
But we can't do it because they told us we can't use the calculator. So what do we do?
Well, can't we establish that tan theta is equal to 4 over 3?
Yes.
Which doesn't
Let me
have
just
to be
pause
that-
here. I would like to hear. Okay, so I'm hearing the right response here. So what we say is, right, tan theta is 4 over 3. So far it was all together. Now we got to ask ourselves, what we got to do is draw a triangle somewhere on this Cartesian plane. The first place I need to ask myself is, which quadrant? We already said that this clue here, we're always going to have two clues. This clue going to tells us that it's either the third or the fourth.
What?
Yeah. We have to do it again, between 180 to 360. We spoke about it. It's either here or there. But now I also know that tan is positive or negative? Positive.
Yeah.
Which one of these two is positive?
Third.
The third. So we gotta draw a triangle. Okay? Now, normally, if you draw a triangle on the third term, then you got 1 mark. Okay? That's probably going to be 1 mark. If you draw a triangle in the correct quad, that's also a mark. Now I gotta decide which one. Okay. Well, question. So Chloe realizes very well. Hang on, sir. He's telling me that tan is positive, but if I'm drawing it in the third quadrant, okay, both the x and the y are negative. Yes, that's true. You're absolutely right. So what we got to decide, which one is 4 and which one is 3, or more like which one is minus 4, which one is minus 3. Okay. What is this? Is this the x or the y?
Hypotenuse.
Is
The y one. Hypotenuse.
It's the y. There's no hypotenuse. Tan is opposite divided by adjacent. So opposite, this is going to be my y. And as Chloe said, there is negative. You're right, the y is minus 4. And then the x, okay, the x is going to be minus 3.
Okay, that doesn't
Okay.
make sense.
I'll pause here. And minus, well, I'll pause in a second. Minus 4 divided by minus 3 is the same as 4 over 3. Okay, I'll pause. Okay, well, maybe I'll just add here, just to remind you, I wrote it down there before. Tan is, theta is always the y over the x. So that clue tells me, I know that's the minus 4 and that's the minus 3. Okay, so that is, well, to get the third mark, I need to be able to find what the r is. And actually, it's a good thing I spoke about it. What did I say? R squared, okay, we are using it. I said we're not going to use it, we are definitely using it. What is r equal?
Negative 3 squared.
Negative 3 squared plus negative 4 squared. Another r squared is equal 9 plus 16, 25. And that tells you that the r equal to 5. That will be the third mark. So we got 1 mark for this. Everyone should get that. 1 mark for that. You should be able to get that. That's also a mark that is a bit more difficult, but you can.
That's fair.
Okay? All right, can we move on? Okay. Now I've got all the information that I need.
yes.
Okay.
Almost. Yeah, I've got all the information. I'm just going to rewrite this, okay? 25. What is sine squared? What is sine? What is sine theta? I'm going to write down.
25.
Sine theta is always y divided by
Oh.
r. I know what the y is. What is the y?
Minus 4.
Minus 4. And the r is
5.
5. But I must square that because they asked me to square sine. If I just had sine theta, it would be minus 4 over 5. But I need to square it. Sine square theta. Okay? Minus 5 cosine theta. What is cosine theta?
Negative
X over r. Okay? And you're right, x is negative 3 over r, which is 5. And then we're done. That's my answer. I will answer question in a minute, but let me just do that. 25, what is that square? So we're squaring the 6 minus 4 to give 16. Squaring the 5 is 25, which is nicely cancelled. Minus 5 minus 5, that cancels out. Minus times minus plus 3. The answer is 19. Okay? I know I was a bit quick here.
What?
Okay?
That's
Let's have a look at that and solve that problem. I'm gonna pause here. Maybe there will be another question. Let's say goodbye. All is good. Let's do some work now. Bye bye.